So part A wants the deceleration of this car. So if it's moving at 15 meters per second, that's its initial velocity. It's coming to a halt, so v is 0. It's decelerating, so its acceleration is minus 2.5, and we want to find t. So using v equals u plus at, 0 equals 15 plus minus 2.5 times t. So 15 divided by 2.5 gives t as 6 seconds. So part B wants a speed time graph. So we know that this maximum speed here is 15 meters per second. So put a 15 on there. And it tells you that the first part of the journey, when the car's accelerating, takes a third of t. So a third of t goes there. And then the next part of the journey, when the speed is constant, takes t seconds. So a third of t plus another t to get there means this must be 4/3 of t. And we've just figured out that the last part of the journey takes 6 seconds. So this must be 4/3 of t plus 6 on the end. Part C wants the value of t. So we know that the area under the speed time graph is equal to the distance travelled, and we know the distance is 885 because it says so in the question. So these three areas here must add up to 885. So my triangle, first of all, I've got half of the base, so that's a third of t, multiplied by the height, which is 15. Then I've got a rectangle in the middle. Now I know that the time is t, so this is 15 times t. And then I've got a triangle at the end. I know that this time along the bottom is 6, so I've got a half of 6 multiplied by the height, which is 15, and this is equal to 885. So if we do a bit of simplifying here, this becomes 2.5 t. This is 15t in the middle, and this is 45. So if we take the 45 off both sides, we've got 17.5 t is equal to 840. So divide through by 17.5, and t comes out to be 48 seconds. So part T wants the value of a, the initial acceleration along this line here. So we know that u is 0. We know that v is 15 meters per second. We know that the time taken is a third of t, and t is 48. So we know the time taken is 16 seconds, and we want to find a. So using v equals u plus at, 15 is equal to a times 16, so a is equal to 15/16. Or if you want that as a decimal, it's 0.9375 meters per second squared. And then finally we want an acceleration time graph. So the initial acceleration we've just worked out is 15/16. So that there's 15/16, and this happens up until a third of t, a third of 48, so up until 16 seconds. And then there's no acceleration because the speed is constant for the next 48 seconds. So 16 plus 48 gives us 64 seconds at this point here. And then for the last part of the journey, the acceleration is minus 2.5. So this down here would be a minus 2.5. And we know that this part of the journey lasts for 6 seconds. So this would take us from 64 up to 70 seconds. I mean, the scale on here is completely wrong, but that makes no difference as long as you've got all the correct numbers marked on.